Okay, now we're looking at applications of systems of linear equations, so ultimately, essentially how we can apply them to solve different types of problems. And so just a quick review, so we're on page 641 in your workbooks, and so going through, we've looked at three different methods for solving systems. So we've got graphing, substitution, and elimination. So before we continue, just taking a look, graphing, obviously, when are you going to graph? You can graph to check, and you can graph as well when no algebraic solution is required. Okay, so substitution and elimination, of course, these are both algebraic. That is not how you spell algebraic. Okay, so both substitution and elimination. Algebraic means substitution. Ideally, we are looking for a coefficient of 1 or -1 so that we can easily isolate one of those variables as a positive 1y or a positive 1x or positive 1a equals, and then substitute that into the other equation so that you'll just have one equation with one unknown that you can solve. So elimination is, again, we need an algebraic solution and no coefficient that is 1 or -1. So again, the idea is that we need to create coefficients that are equal or ideally opposite by multiplying one or both equations by different values, so that we can have them being the same or opposite, so that we can add or subtract, so that we eliminate one of the variables. Okay, let's take a look at problem solving then. So just as we were solving equations in previous years, the biggest thing that you need to do is to introduce those variables, label those variables clearly. Okay, so if we're talking about, you know, nickels, are you talking about the value of the nickels? Are you talking about the number of the nickels? So be specific, especially with the units where applicable. Okay, once we've labeled, if we've done a really great job labeling, then writing out your equations should be quite simple. Okay, because each of your equations is telling a story. Okay, and it should make sense. Once we have our system, we're going to solve using whichever means makes sense, so either graphing, elimination, or substitution, and then we will answer the problem and check the solution. So again, with the check, my suggestion is to check using the context of the question. So you don't necessarily want to verify in the same way that we previously have by substituting it into the equations, because we made the equations. So even though it may verify the equations and check out, if we wrote the equations wrong, it doesn't necessarily mean for sure, guarantee, that we've solved the problem correctly. Okay, so let's take a look at a few examples they've got, a few different assorted types. So number applications. So these are probably a little bit contrived, but let's just go with this. So the difference of two numbers is 9. The larger number is 3 more than twice the smaller number. Find the numbers. So we've actually done similar questions like this last year, and we used one variable. Theoretically, using two numbers should be a little simpler. So let's decide our two numbers. So perhaps x is the smaller number, and y is then going to be our larger number. So if the larger number is 3 more than twice the smaller number, there's our first equation. So twice the smaller number, so 2 times x, plus 3 should give us the larger number. So 2x plus 3 equals y. The other equation is the difference between the two numbers is 9, meaning that the smaller number plus 9 gives us the larger number. The larger number minus the smaller number is equal to 9. So either or will work. So if I say the small number plus 9 is equal to y, so we've got equation 1 and we've got equation 2. So in this particular case, if we've got our system, two equations, two unknowns, in looking at them a little bit more closely, we've got y already isolated, coefficient of 1, so it's a perfect setup to do substitution. So if 2x plus 3 equals y, x plus 9 also equals y, then they must equal to each other. So we can say then that, let's just come up here, then 2x plus 3 must equal x plus 9. And there we have it. We've got our equation with one equation, one unknown. We can go ahead and solve. So all the x's go onto one side. So if I subtract x, then we've got x plus 3 is equal to 9. Subtract 3 from each side. So x is equal to 6. Then let's substitute into one of the equations to come up with the other one, the other value. And so in the second equation, x plus 9 is equal to y, so that means 6 plus 9 is equal to y, so y must equal 15. So in terms of my check, I am just looking at it in context. So is the difference between the two numbers 9? So 15 minus 6 equals 9. Yep, that works. The larger number, 3 more than twice the smaller number. So if I double my smaller number and add 3 to it, that is indeed 15, which is the larger number, so that works as well. Find the numbers, so I'm going to write a statement being clear. So the numbers are 6 and 15. Excellent. Okay, let's move on. So the perimeter of a rectangle is 40 meters. The width is 4 meters less than the length. Find the dimensions of the rectangle. Again, I think we solved one similar to this last year as well, but let's go with using two variables. So we've got W as being the width, and that is in meters, and the length is L. And we'll say that is obviously also in meters. So what do we know? The perimeter is 40, so we know that 2 widths plus 2 lengths is equal to 40. We also know that the width is 4 meters less than the length, so length minus 4 is equal to the width. So once again, we've got equation 1, equation 2, and W is nicely isolated already with a coefficient of 1. That means that we can easily and quickly substitute in 2 into our first equation. So we've got 2 times L minus 4 plus 2L is equal to 40. Let's distribute that 2 in, so 2L minus 8 plus 2L is equal to 40. Combine those L's, we have 4L minus 8 equals 40. Add 8 to both sides, so 4L is equal to 48, and divide both sides by 4, so L is equal to 12. So that tells us our length is 12. We know, again, I can substitute that into either equation 1 or into equation 2, but since we know simply that the width is 4 meters less than the length, so width is equal to then 12 minus 4, so the width is equal to 8. So in the context of it, we can do a couple of things. I could quickly draw a picture even, and so we can see these are each 12, that is, the widths are each 8, then then that quickly shows me that my perimeter is in fact 40 and the width is 4 meters less than the length. Awesome. So the dimensions of the rectangle, then we'll just write a quick statement. So dimensions are going to be 8 meters by 12 meters. And that will do it for class example number 2. Okay, money applications. So those coin questions that we looked at last year as well, we can do that with a single variable, which we've done, or now with the system, we can do it with 2 variables. So we've got $5 bills and $10 bills. So if we say that F is equal to the number of $5 bills and T is going to be the number of $10 bills. So we know that there's 33 bills in total. So the number of $5 bills, F, plus T, the number of $10 bills, is equal to 33. Okay, $260 is my total, so that means that if I have F is the number of $5 bills, then 5F is the value of my $5 bills, plus the value of my $10 bills, 10T, is going to equal to $260. And there we have it. We've got our 2 equations and 2 unknowns. So once again, we could do substitution if we wanted to, because F and T both have coefficients of 1, so it's very easy to isolate one of those. Or if we wanted to, we could also do an elimination. So either or. Let's do elimination just for fun, since we haven't done that just yet today. So we'll take equation 1, I'll just change the color here. I'm going to take equation 1 and I'm going to multiply that by 5. So we'll do 5 times equation 1. I'll write it right underneath equation 2. In fact, I'm actually going to multiply it by -5, so that I'm going to have the opposite. So -5F minus 5T is equal to -165. And then we'll add these together. So the F's then eliminate each other. 10T plus -5T, so we're adding, is 5T, and 260 plus -165 or -165 is then 95, and divide both sides by 5. And so T is then 19, knowing that we have 33 bills in total. So then F is going to equal 33 minus 19, or 14. So let's take a look. First off, so our check, do we have 33 bills in total? Well, 19 plus 14 is 33. That is a check. 19 represents the number of $10 bills. So 19 times $10 a piece is $190. If I have 14 $5 bills, then that is $70. And in total, we have then $260, which confirms what the question has as well. So in total, how many of each? So he has then 19 $10 bills and 14 $5 bills. Excellent. Okay, let's take a look at class example number 4. So Laura has invested in an inheritance of $48,000 in 2 different mutual funds, and it says that at the end of 1 year, one fund earned 10.5% interest, and the other fund had earned 12% interest. So if she receives a total of $5,520 in interest, how much did she invest in each mutual fund? Okay, so let's start by labeling again. So what do we know is we've got the 2 different amounts invested in mutual funds. So we'll call those perhaps we can call them X and Y, or A and B. So let's just go with X. is amount in first fund, and then Y is the amount in the second fund. So what do we know? And the amount meaning dollar amount. So our first equation then, if the total amount she's invested is 48,000, so we know the amount invested in the first fund, X, plus the amount invested in the second fund, Y, is going to have a total amount of $48,000. So that's our first equation. Our second equation is then having to do with the interest. So if she's invested X dollars in the first fund and earning 10.5%, then the dollar amount is going to end up being 0.105 X, because that tells us that that is 10.5%. So if we change that into a decimal by dividing by 100, so decimal 105 times X, that gives us the amount that she's earned on interest for the first fund. And we'll do the same for the second fund, so plus 0.12Y, and the total interest earned is $5,520 in interest. And so that is our second equation. So now that we've got our two equations, we can decide whether or not we want to solve using elimination or solve using substitution. Totally up to you. Certainly, because we have variables with coefficients of 1 in both equation 1, we can choose to isolate one of those to make it easier for us, and I would probably suggest that you do that, since having the decimals is not going to be as easy for elimination. Certainly we could multiply equation 2 by 1,000 to get rid of the decimals, but then we end up with some pretty large numbers as well, because you'd have to multiply that 5,520 by 1,000 as well. So let's take that equation 1, and we'll isolate either X or Y. And so if we isolate, let's just say we'll isolate Y. So from 1, we're going to take that and we'll say subtract X from each side. So Y is equal to 48,000 minus X. And then we're going to call that 1A, we'll say, and we'll substitute that in to the equation 2. So that means we'll have 0.105x plus 0.12, and instead of y is 48,000 minus x, and that is equal to 5,520. So let's go ahead and calculate that then. So we'll need to distribute the 0.12. So we'll have, whoops, my pen is spinning. So we'll have 0.105x plus 5,760 minus 0.12x is equal to 5,520. And then let's combine that our x's. So if we've got decimal 105x and then minus decimal 12x, that gives us then negative 0.015x. And at the same time, we will subtract 5,760 from each side. So that leaves us with then negative 240. To isolate our x, we now need to divide both sides by negative 0.015. And that gives us then, let's use the calculator for this one, divided by 0.015. So that gives us x is 16,000. And that seems like a large number, other than the fact that we've got a total of $48,000 to invest. So that seems reasonable. $16,000 is ending up being 1/3 of that amount. And so x plus y is 48,000. So that tells us then y is going to equal to 48,000 minus the 16,000, which is $32,000. And so we can take a look at doing a check. So our verification would mean, does the total add up to 48,000? Yes, absolutely. Let's take a look at the interest piece of that. So let's see if we can squeeze this in the slide here. So if I know that I earn 10.5% interest on 16,000, so 10.5% of 16,000, so that's going to equal 0.105 times 16,000, and so then we have 16,000 times 0.105, and that gives us $1,680 was earned in interest from that first fund. And then in our second fund, we are earning 12% of $32,000, and so 0.12 times 32,000 is then going to be $3,840, and if we add those together, 1,680 plus 3,840, we do in fact get our total amount of interest, which is $5,520 total. So that works out, which means we can answer a question: how much did she invest in each mutual fund? And so we'll squeeze that over here. Then Laura invested $16,000 in the first fund and $32,000 in the other fund. So as usual, please check in with me if you have any particular questions. Remember, our main goals are: 1, label your variables; 2, write your equations; 3, solve the system using either substitution or elimination, and then make sure that you're solving for both variables. Check your solution, ideally using the context of the question, since we're not guaranteed that our equations are correct, and then write your finishing statement. Thank you.